So we are dealing with the 10th problem in this series. The 10th problem in this series, that is problem 3.10, and the problem is stating a point charge Q is located at the center of a thin ring of radius capital R with uniformly distributed charge minus Q. Find the magnitude of the electric field vector at the point lying on the axis of the ring at a distance x from its center if x is greater than R. So if we start approaching this problem, the first thing that we do is we draw a diagrammatic representation of the situation which is given to us. So we have a thin ring and it is distributed with a negative charge all over it. So a negative charge is distributed all over this ring. So the result will be same which we have obtained in the problem 3.9. We will be using the same result. The only difference will be that the electric field will be directed towards the center of the ring on its axis. Now the next information that is given to us is a point charge Q is located at the center of this ring. So we also have a point charge which is plus Q located at the center of this ring. The ring is of radius capital R. And we are discussing electric field strength at a distance x from the center of this ring. So if we write the results, so we can say that the electric field due to the negative charge is directed towards the center of the ring. So E due to a ring which is a negative charge, so we can write it as KQX. We are writing it as K, that is 1 by 4 pi epsilon naught QX upon x square plus r square to the power 3 by 2, and it must be kept in mind that it is directed towards the center of the ring. Towards the center of the ring. Now due to the point charge, E due to point charge, so this will be 1 by 4 pi epsilon naught Q by x square, and this is directed away from the center. Away from the center. So we have these two values, and it is evident that the magnitude due to the point charge will be greater than the electric field due to the ring, and therefore if we are writing the net value, so in the net value we will be subtracting the larger electric field with the smaller electric field. Therefore we can write it as Q upon 4 pi epsilon naught x square minus Qx upon 4 pi epsilon naught x square plus r square to the power 3 by 2. So this is the term that we have. Now all we need to do is to resolve this term and use the condition x greater than r. So we are writing it as Q upon 4 pi epsilon naught x square 1 minus 1 plus r square by x square to the power minus 3 by 2. So this term is taken out, so we have left with 1 minus of x upon x square plus r square to the power 3 by 2. If we divide by x in this term, so we get this term as r square by x square to the power minus 3 by 2. Now we use binomial approximation since x is greater than r, so therefore we can say that r square by x square is less than 1. So if this value is less than 1, then we can say that E can be approximated as Q upon 4 pi epsilon naught x square, and we can write it as 1 minus 3 by 2 r square by x square. So we are using binomial approximation, and since this value is less than 1, we can say that the magnitude of E is turning out to be 3Q r square by 8 pi epsilon naught x to the power 4. So this is the required answer for the problem which we have solved, problem number 3.10, where we have used binomial approximation